So for this lesson, we are going to look at parallel lines, and we're going to start to talk about the concept of how do we do a proof. So the first thing we're going to do is solve a problem. But we're going to look at this in terms of, well, how would we do it as a proof? We could all solve this algebraically and find that x is 7, but we want to actually do it as a proof. So when you're doing a proof, typically you'll see a 2-column setup, where the left-hand side are your statements and your right-hand side will be your reasons. You always need to have a reason for every statement you put down. Very first thing you do, and this is kind of the nice little easy way to get into a proof, is you always start your proof off with the given. So whatever they tell you is your given. In this case, 6x minus 12 equals 4x plus 2. You're going to have that as your statement, and the reason that we can say this, well, is it's given. Okay, so if we were to solve this proof, we would go through, and how would we solve it algebraically? Well, the next thing we would maybe do is perhaps subtract 4 from each side. So normally in a proof you wouldn't have to show this, but just so you can see what we're doing, if I were to subtract 4 from each side, my next statement would say 2x minus 12 equals 2. And when we're trying to come up with a reason, well, we say, what did we do, or why do we know this? Where did this come from? Well, we had to subtract. So our rule over here is our subtraction rule. Okay, continuing to solve this. So if we were to do the next step, we would want to add the 12 over, which would give us a statement that would look like 2x plus 14. And again, we'd say, how did we do this? Well, we did this by adding, so addition. And lastly, we want to solve for x. So how do I get x to be by itself? I'd have to divide through by 2. So again, our rule over here is division. And you're going to notice you're done when you have your very last line is what you're proving. Because then you've actually done the proof. You've completed. You've shown why x is 7. You have proven it. That's when you know you're done. Okay, so some little information about proofs. A proof is an explanation of how a statement follows a logical order from start to finish, and it's accepted as true. So that's what we did up above. We use things like theorems and postulates. Theorems we have talked about before. It's something that can be proven true. And we typically see them in the form of an if-then. If something happens, then something else happens. Another thing that we can use is a postulate. So for instance, here's an example of a postulate. So if 2 lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So this came from our last section. And the picture that would go with this maybe looks something like this. These are our corresponding angles. So if I have corresponding angles and I know they're congruent, well, that only happens if my lines are parallel. Okay, so that's a statement assumed to be true. So when we are looking at these, and things to keep in mind, properties of parallel lines cut by a transversal are only true if the lines are parallel. So things like alternate interior angles are congruent, alternate exterior angles are congruent, only true if the lines are parallel. So we have the following angles, and it says, given the following information, we have to figure out which lines, if any, are parallel. Okay, so I'm going to take a look at angle 12, and I'm going to trace out angle 12. So angle 12 is right here, and I can see when I trace that angle, I'm highlighting 2 lines, line L and line B. And then I'm going to look at angle 14 and do the same thing. When I trace out that angle, I see I'm highlighting 2 lines, line L again and line A. So that should help clue you into which lines are parallel. The one that we've traced out twice, that becomes the transversal. The other ones that we've only touched once, line A and line B, those become the parallel lines. So I could say here A is parallel to B, and then we have to identify, well, what type of angles are 12 and 14? Well, those are alternate interior angles. So when it's saying state the postulate or theorem that justifies your answer, we could say something like if alternate, and I'm going to abbreviate, abbreviations are okay. If alternate interior angles are congruent, then the lines are parallel. So there's that if-then statement that we were talking about up above. Okay, try another set. Angle 4 and angle 15. So if we highlight angle 4, and I'm going to trace it out so I can see both lines. Line M was traced and line A was traced. And if I look at angle 15, angle 15 is up here. So line L and line A. So again, I can see A was traced twice. So what does that mean? Well, the ones that were traced once, M and L, those are my parallel lines. So I'm going to say L is parallel to M. And then we have to figure out what type of angles we have. So here's angle 4 and here's angle 15. And those are our corresponding angles. So a theorem we could write, again, if then, if, state your angle name, corresponding angles are congruent, then the lines are parallel. So most of these statements are going to be in the form of if then, and it's always going to say if, state the angle name, are, state the property. So in this case, congruent. We could say if alternate exterior angles are congruent, then the lines are parallel. So you're going to see that they're very similar every time we write these out. So here's an example. Here's a theorem. If two lines in a plane are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. And we're going to prove this theorem. And one really big thing here is when you are proving a theorem, you can't use that in the proof. I'm proving it. I don't know if it's true or not. So I have to use other methods. So basically it's saying I can't say anything about alternate interior angles in this proof. Okay, so we have our two columns set up. We have our two parallel lines. We have a picture. Notice we have our given and our prove. This is like our start to the proof, and this is our stop of the proof. Okay, so looking at this picture, always look at the information, always see what you're given. So, okay, notice we have those alternate interior angles. They gave those to us. I'm trying to prove the lines are parallel. So what you need to do is state other pieces of information that that are true right now without the lines needing to be parallel. So for instance, in line 2, it's already told to us that angle 4 and angle 3 are congruent. So if I look up at the picture, here's angle 4, here's angle 3. Well, I can see they're vertical angles. So the reason for saying 4 is congruent to 3 is that vertical angles are congruent. They're always congruent. I can tell you that no matter if I have parallel lines or not. Okay, now step 3 we have to be careful because keep in mind, lines we do not know if they are parallel. So if you're looking at the picture saying, oh, they're corresponding angles, those are congruent, you have to stop and ask yourself, but when do I know corresponding angles are congruent? It's only when the lines are parallel. But that's what we're proving right now, so I can't use that. So I have to figure out, well, how else would I know 1 and 4 are congruent? Look at the information that you have up above in your proof. I see something similar about them. I see that they're both equal or congruent to angle 3. So if 1's congruent to 3 and 4's congruent to 3, well, then they have to be congruent to each other. That's kind of one of those, like we would say in class, if they're equal, set them equal. Well, they're both equal to 3, so I'm going to take these two leftover parts and set them equal. So what we do, whenever you can say if they're equal, set them equal, that's a substitution. And we use substitutions quite a bit in proof. I am replacing, another way to look at this is like saying anywhere I see an angle 3, which is there, I'm going to replace it with a 4 because I know that they're equal. So now we have found that angle 1 is in fact congruent to angle 4. So now I look at the picture and I say, oh, well, they're corresponding, and we've just shown that those angles are congruent. So when is the only way, or when, if they are congruent, what's going to happen? Well, they can only be congruent if our lines are parallel. So over here we're going to say if corresponding angles are congruent, then the lines are parallel. So again, notice in the proof, we were proving the fact that if we had alternate interior angles congruent, the lines are parallel. We did that. We did not state anything in our proof about alternate interior angles. Okay, and our very last one. Now this is a little bit different. And the thing that I really want you to notice on this proof is they're just giving you a diagram, and actually they didn't even tell you what the given in the proof is. So it's our job to come up with the given in the proof. So we have given the diagram pictured to the right. We're proving that the vertical angles are congruent. Okay, so the given, all they've said is we have a diagram. Our diagram is pictured at the right. So if you just said diagram, that would work. That would be okay. You could go over here and you could label these points. And I could say we're given, instead of diagram, here's a different option. You could say line AB and line CD intersect at E, and maybe we could call that center point E. That's an option. Okay, and what are we proving? It says prove that vertical angles are congruent. Well, so we have options here. So a set of vertical angles is angle 1 and angle 3, and I want to prove that they are congruent. Okay, so I'm going to try and take you through this. This is a little bit more of a difficult proof. You could stop this, try this on your own, and then see how you do. As always, we know that we're starting with the given, and I'm just going to say diagram. And step 2, looking at the picture, I'm taking a look at where angles 1 and 2 fall, and I see that they're next to each other on a line. The reason I'm looking at 1 and 2 is because I need to know something about angle 1 in order to complete this proof. So I'm going to state here angle 1 and angle 2 form a linear pair. Okay. And if I take a look here, I can say the same thing for angle 3 and angle 2. They also form a linear pair. I'm going to write that all down together. So I'm going to say angle 3 and angle 2 form a linear pair. And the reason, well, that's our definition. It's a definition of a linear pair, meaning we have two angles next to each other on a line. So if I have two angles next to each other on a line, well, I know that they're going to be supplementary. So I can say angle 1 and angle 2 are supplementary. But I could do the same for angle 3 and angle 2. And the reason we know this is linear pairs are supplementary. So your reasons are just explaining what you're doing. Your reasons are trying to show you why things work. Okay, so what do we notice about supplementary angles? Well, we know supplementary angles add up and equal 180 degrees. So I'm going to say that for both. Angle 1 and angle 2 add to equal 180. Angle 3 and angle 2 add to equal 180. And this, we could just say, well, we know supplementary angles equal 180. Just explaining again what we know. Keep in mind, we're trying to get 1 and 3 to be the same size. That's our idea. We're trying to prove that they're congruent. Now, back up here, similar to the proof that we did before, I can see they're both equal to 180. And this is one of those cases where I would say, if they're equal, set them equal. So I'm going to take the two equations, and I'm going to set them equal to each other. And that, again, if they're equal, set them equal, That's a substitution. Okay, so now notice what we have, kind of like that algebra proof that we did in the beginning. Measure of angle 2 is on each side. I could get rid of angle 2. And if I think about this from an algebra standpoint, think if I tried to subtract an angle 2 from one side, subtract an angle 2 from the other, notice what happens, what we're left with. The measure of angle 1 equals the measure of angle 3, and we did that because of subtraction. And if we want to be really technical to finish this off, the very last thing that we could say is angle 1 is congruent to angle 3 to get our proof statement to look 100% the same. And the reason here is we can just say angles with equal measures are congruent. Now I know that that's a lot, that's a big proof. First time really looking at proofs, I don't want you to stress out and say I can't do this. We can. We're just looking at this. We're trying to get an idea, trying to see how they flow. We're going to practice this a lot more in class. You can always try this again now that you've seen this happen. You can try this on a separate sheet of paper and see if you can recreate this. So that's our first experience with proofs. I hope this was helpful. Feel free to watch this again if you need, and come see me after school if you have any questions. Okay, don't forget to like and subscribe.